This is the fourth video of the section, generating Poisson random variates. In the previous video, we generated binomial random variates. Now let's know about Poisson distribution. In this video, we demonstrate how to generate samples from Poisson distribution. You need to prepare your environment with R installed. Poisson distribution is best to use when expressing the probability of events occurring with a fixed time interval. These events are assumed to happen with a known mean rate, lambda, and the event of the time is independent of the last event. Poisson distribution can be applied to examples such as incoming calls to customer service. In a Poisson experiment, we can characterize the mean number of successes that occur in a specified region, lambda, against the actual number of successes, x, with this formula. So let's start. Similar to normal distribution, we can use rPois to generate samples from Poisson distribution. We can also plot sample data from a Poisson distribution into a histogram using hist function. Here you can see the histogram. We can then obtain the height of the distribution function at x equals 2. We use the dpois function and we can see here the height is 0.2240418. We can use bar plot to draw samples generated from the dpois function. You can see the bar plot of the Poisson distribution here. Next, you can compute the proportion of area covered from x equals 1 to 5 with the ppois function. You can execute the code and you can see the output is 5. You can also compare the density plot of samples generated using different lambda values. Now let's write the code for that. First, we start with one Poisson distribution. You can see the histogram. Now let's use Poisson 2 and see what happens. You can see the changes in the histogram. Likewise, when we include more histograms, the density plot changes. Similar to normal distribution, we can use gpois, the probability quantile function, to invert cumulative distribution of Poisson distribution. Here, the output is 2. Amazing! So we learned to generate Poisson random variates in this video. In the next video, we'll see how to take samples from a normal distribution.